Welcome to today's webinar on how to close the human intervention gap. My name is Ellie Allen Bathe, and I'm a content marketing manager here at Flexware. Before we get started with some introductions of our presenters, just a couple quick housekeeping notes. First, if you have any questions throughout the presentation, feel free to drop those in the questions tab of the toolbar. We'll answer those after we wrap up the presentation portion of today's webinar. Secondly, the session is being recorded, and we'll make that recording available to you shortly after we wrap up today. Now that that's out of the way, I'd like to introduce today's speakers. I'm joined today by Celine Ambanasor, Brooks Corfidge, Nader Koha, and Jonathan Geva. Celine is the Director of Customer Success at IGear, where she helps manufacturing organizations improve operational performance through digital solutions. Her work focuses on customer adoption, operational visibility, and connecting people, machines, and systems to drive better decisions. Brooks is the Business Development and Integrator Program Lead at IGear. He partners with manufacturers, industrial companies, and systems integrators to deliver connected software solutions that improve operational response, visibility, and efficiency. And Nader is an engagement manager at Flexware. He has deep expertise in smart manufacturing and a strong track record of delivering transformative solutions that drive measurable results. And finally, Jonathan is a solutions architect at Flexware, and he's focused on helping manufacturers unlock the full value of their operational data. He brings a practical, results-driven approach to solving complex challenges. Jonathan, I'll go ahead and hand it over to you to get us started.
Thanks so much, Ellie. I appreciate it. So good afternoon, all, and thank you for joining us. My name is Jonathan, and today we're going to discuss a topic that sits at the intersection of manufacturing operations, automation systems, and digital transformation. So manufacturers have invested heavily in industrial platforms, driving machine data collection, anomaly detection, and equipment analytics. And those systems help us understand when a machine has stopped, what fault may have occurred, and how production performance was affected. What is often less clear, we find, is what happened after the event was detected. The human aspect: who received the information, when did someone accept ownership, was the proper expertise engaged, and where specifically was response time consumed. Those questions describe the human response process that connects machine data to production recovery. Nearly every facility has some form of this process, but it is frequently informally and only partially observable. Most organizations can establish when production stops and when it restarts. Reconstructing the activities in between often depends on things like radio traffic, individual recollection, or a maintenance log completed after the incident. Today, we'll examine that interval as a measurable manufacturing process. We're going to define the human intervention gap, review the practices that improve response performance, and then show how SQUEAKS supports that operating model. The objective is not to simply notify faster, it is to do so more consistently, transparently, and improve response from detection through resolution. So today's agenda will begin by defining that human intervention gap and the business impact of leaving the response process unmeasured. We will then take a look at the most common causes of delay and the operating practices that address them: clear ownership, structured escalation, better troubleshooting context, and consistent measurement. From there, we will introduce SQUEAKS as the platform that puts those practices into actual operation. We'll follow this by a live technical demonstration and a discussion with the IGear team about what manufacturers experience in the field. Now, as we move through the presentation, the central question is pretty straightforward. Once a machine identifies a problem, how effectively does the organization convert that information into appropriate action? Let's get started. So to understand this, we should look at the landscape. The statistics on this slide, with insight provided from automotive and transportation manufacturers, point to a familiar contradiction that we see. Manufacturers have more machine data than ever, yet unplanned downtime remains very expensive, and response delays are still commonly measured in minutes or hours rather than seconds. The detection itself is generally not the limitation here. A PLC, sensor, modern SCADA system, or any other connected sources can identify and timestamp an abnormal machine condition almost immediately. The more difficult question becomes what happens once that information enters an organization. Many facilities can report downtime and OEE in detail, but they cannot consistently report how long it took to establish ownership, engage the appropriate responders, or escalate an unresolved incident. That is all to say the activities between detection and resolution. That is why the statistic about companies tracking OEE but not human response time is pretty important. It identifies a blind spot between machine visibility and operational action. Machine data tells us that an event did occur. Response data tells us how an organization reacted to that event. Two lines can experience the same fault and still have very different production outcomes because one facility has a defined response path and the other relies on availability, individual knowledge, and informal communication pathways. The opportunity is therefore not to replace the machine data organizations already have, but it is to complete that operational picture by measuring response that follows the machine event. That distinction has practical business value. Not every equipment failure can be prevented immediately, but the duration and operational impact of many incidents can be influenced by the quality of the response. Response performance is therefore a controllable variable and one that can be improved on without waiting for a major controls or equipment upgrade or a large modernization project. So we have other panelists here today, and we are joined by Brooks and Selena at iGear. Brooks, I was hoping you could provide some insight into the work with customers and why downtime is still affecting manufacturers to the rate that we see today.
Yeah, it's a good question, Jonathan. I think the screen does a really good job of showing that, time is of the essence in the manufacturing space. And for us, one really key theme that we've seen across our customers is this idea of open loop systems. And that really leads to lack of accountability around incidents. It also leads to lack of visibility, having to be right at the line to see what's occurring. So you have to really be proximity based, can't see it from anywhere. And lastly, this idea of lack of tracking how the workflow is progressing. So the open loop systems can really lead to increased downtime, which is cost, as you see on this page.
Yeah, absolutely, Brooke. I think that really sets us on the right path and the tone to look at the actual human intervention gap. That's what we're discussing and how we can address that through some implemented practices. So looking deeper into this human intervention gap, we've got a pretty simple diagram showing the basic incident life cycle. We've seen this many times. Machine detects an issue, an alert is generated, somebody acknowledges that alert, and the issue is resolved. Most manufacturing systems capture the first event extremely well. We have good systems that capture changes in state and so forth, and eventually capture the final outcome. And that interval is usually the only visible aspect. But what happens in between that is where that visibility commonly falls away. It is useful to separate that interval into distinct measures rather than treating an entire downtime as one continuous clock. First, the notification time. How quickly did the event reach the appropriate audience? Next, that acknowledgement time, often expressed as mean time to acknowledge or MTTA. How long did it take for someone to accept ownership over the incident? Then there is the response or engagement time. When did a qualified personnel actually begin addressing the incident? Finally, there is resolution time. How long did diagnosis, repair, verification, and restart require? Different organizations use these terms differently, such as MTTR, so the precise label matters less than defining the start and end points consistently. Separating these intervals makes the data actionable. A notification problem requires a different corrective action than a troubleshooting problem. A delayed acknowledgement may point to routing or ownership, and a long resolution may point to documentation, training, parts availability, or access to specialized support. This human intervention gap is a portion of this lifecycle that is not consistently observed or managed. Once those transitions are captured, the response process can be benchmarked and improved rather than reconstructed after the incident. So what is illustrated on the slide is a simple workflow to demonstrate the human intervention gap. Celine, as we were just introducing this idea of workflows, could you tell us what some of the effective ways to manage manufacturers' unique workflows and processes are?
Yeah, absolutely. Great question, Jonathan. So, in practice, every manufacturer has unique processes, roles, and escalation paths for their different types of incidents and issues that are occurring in their operations. So, workflows may vary by plant, production line, machine, asset, shift, product family, and other operational contexts. And what we found working closely in the manufacturing space is that it's really important for not only team members to be able to effectively respond to workflows and interact with their workflows in an effective manner that's simple and intuitive, but also the ability to create workflow processes needs to be very simple, where a user can define states or the actions that are required, or maybe even time-based automatic escalation rules without having to get a developer involved, where it's something where it's as easy for anyone to be able to create, as these processes are constantly changing, and now that they have the information to learn from them and learn from their processes with a digital format, how can they make sure they have a flexible type of system to where if the process does change, they can easily adapt their workflow to that change, again, without having to get a software developer involved.
Yeah, thank you, Celine. I think that's really important to have a flexible system that actually fits the operational structure of these unique manufacturers. So appreciate that. And I think before we jump into just the technological strategies for improving this incident response or addressing this gap, I'd like to take a moment and just evaluate some common reasons why the human gap exists and what we're seeing today in the manufacturing environment. So here we have just six causes on this slide. They generally fall into three main categories: a signal quality, a process ownership, and an operational visibility issue. So a few that we know of quite well: alert fatigue and knowledge gaps. These affect that signal quality. When teams are receiving too many undifferentiated notifications, such as we see on like really busy and-on boards or loud manufacturing floors, important events compete with just routine alarms that are every day or nuisance alarms. And then when an alert provides only a code for a description, such as like from a PLC tag, the responder may still need to search for additional information or rope in other individuals to address that. So the answer is not simply to just add more notification channels, it's to be more deliberate about which conditions require an organized response and how they are prioritized and what information should accompany them. That work is closely related to alarm rationalization. The response process is only as effective as the quality of the events that are entering and actually reaching the end individuals who need to address these issues. So that leads us to ownership. And I think unclear ownership and manual processes affect the execution of our incident response. Sending an alert to a group or into the ether does not guarantee that anyone has accepted responsibility. Open loop systems, as Brooke mentions, just like phone calls, radios, paper logs, may move information around a factory, but they do not guarantee that someone's going to actually follow through on that. And they depend on that individual follow through and do not create a reliable workflow record. And that's kind of what leads us into this last item, this limited visibility and lack of measurement. Supervisors may know that an incident exists, that there's an alarm out there, but they may not know whether it has been acknowledged, escalated, is actively being worked on. And after the event, oftentimes we see operations and maintenance may have different interpretations of where the delay occurred because neither team has a complete timeline of this incident response as a whole. These conditions should not be framed as like individual failures. In most cases, what we see, capable people are absolutely working within a process that does not have clearly defined ownership, proper information, escalation routing, or measurement tools. And that distinction matters because sustainable improvement comes from designing a better shared process, not by simply asking people to just respond faster to alarms or just fix things faster within an already pretty ambiguous system. So for us, a productive discovery process, therefore, looks beyond just the software basis. It examines which events truly require intervention, who owns what today, and how does shift coverage changes and various things affect the workflow. Where is there specialist knowledge? Where does it reside? And which exact machine events requires it? And how does a team currently determine that an incident is complete and done? So Celine, I'll pass this off to you. We often see manufacturing operations holding these end of shift meetings, looking at all the downtimes, discussing this gap in production potentially. What do manufacturers need to make these discussions more productive?
Yeah, great question. So we see a lot of times, as you mentioned, at the end of a shift, manufacturing teams, operations teams huddle up and really review what happened during that shift, any downtime events, and what are the reason codes for that. But a lot of time those meetings are really centered around, manual entry of reason codes for downtime, which sometimes makes it really challenging to identify where are the biggest areas for improvement in your downtime. How can you reduce costs and how can you reduce downtime overall? And so a lot of times, if let's say an operator or team leader doesn't have time to enter in a reason code before the end of the shift meeting, that information sometimes can also be lost. But even with that, if you're entering in reason codes like material, machine, man, for example, don't really get an explanation of what happened, how the issue unfolded, how long each step of the process for resolution took, and who responded and where delayed occurs. And so when you're able to capture response times and the mean time to respond, mean time to acknowledge, resolution times, and a full workflow history, as well as the operator input, then you get a complete picture of that event, not just a reason code. And more importantly, it helps teams better understand where time is actually being lost through the response process, and ultimately gives them a better understanding of where their bottlenecks are and creates a measurable baseline for continuous improvement and reducing that downtime.
Yeah, thanks so much, Celine. I think so many teams would benefit from having clear discussion around data, especially in those meetings. So I appreciate that. And we'll just continue to dig a little bit deeper into these proven strategies and then kind of flow into how do we enable this in a technological manner? How do we operationalize it? Um, so the practices on this slide create the operating model for a more consistent response process. The strongest implementations do not attempt to just redesign every alarm or every workflow at once. I think they normally begin with a focused set of the highest impact events where ownership, business consequence, and desired responses are fairly well understood. So first, define the ownership. Each alert type should map to an expected first responder based on factors such as asset location, shift, severity, required skill set. The objective is to remove that ambiguity the moment the incident begins. Second is defining the escalation in advance. If an alert is not acknowledged within an expected window, or if the first responder needs additional expertise, the workflow should move to the next tier without relying on some manual process or kind of falling into that open loop aspect of just calling out for help. Third is providing the context with the alert. We see every day of alarm banners with very limited information for teams that are stretched quite thin across a lot of automation. So relevant procedures, photographs, drawings, known causes, diagnostic steps, all this stuff reduces the searching for information and really helps standardize that starting point for troubleshooting, especially when you're onboarding individuals to a very complex automation environment. Fourth is this measurement aspect. So measuring the complete life cycle is a very practical KPI. So we can potentially look at that mean time to acknowledge that you mentioned, Celine, time to active response, actually working on the item, time to resolution, escalation rates, how often we need to call somebody else's backup, first tier resolution rates, and then we can benchmark these against defined performance targets. So I think that changes the discussion quite a bit about incident resolution from just this one downtime number to a more granular aspect that we can actually improve upon. The terminology should be already agreed upon beforehand, and I think we need definitions of when each clock starts and stops, and we're going to kind of showcase how that works within the demonstration. Finally, we'll use the resulting visibility for continuous improvement. This data should support a joint discussion between very different departments: operation, maintenance, reliability, engineering, leadership. All these individuals can have more information to make better decisions. So instead of debating whether a response was slow, the team can really just identify whether time was lost in notification, acknowledgement, escalation, and that just creates a more constructive conversation, as we've noted in those, especially those end of shift meetings, and overall improvement. So the shift shown on the right captures the outcomes of this change, from more of a reactive and ad hoc response to these defined workflows supported by like machine data and human response information. And so, Brooks, we've discussed these strategies, and as we kind of move into this demonstration process, could you provide just some information on how iGear has developed SQUEAKS in lockstep with like facilitating this shift?
Yeah, I'd say over the last 25 years as a company, we've really experienced these operational challenges firsthand. And so to close this gap, we built a platform called SQUEAKS to really orchestrate the human response to these incidents. So we're taking a more closed loop system approach compared to the current open loop system to really target alerts to the right responder, drive action through automated workflows, and that allows you to take incidents to the next level past detection. And at the end of the day, from there, we've added functionality over the last year or so to allow for reporting and out-of-box metrics that allow teams to get more really use out of their data that they're collecting, of where they're losing time between event detection and resolution, maybe even different responder performances. These are all things that they maybe didn't have before, and now with SQUEAKS that they're able to get with our platform configured correctly.
No, fantastic. Well, I appreciate that. And that's a good introduction. So just kind of calling as a user so far, SQUEAKS is really designed to operational the practices we just discussed. We refer to it as a response orchestration platform because it manages more than just like the notification aspect, which we're very familiar with most SCADA systems. It connects to the event source fairly openly through API or other machine connectivity. And then you can have very easily configurable aspects with no code or low code, such as expected responder, escalation paths, and troubleshooting context, and then that kind of full response record. And as a data person, it's extremely important to me that that's embedded within the system and easy to grab. So taken together, these capabilities create a complete and measurable incident record. And I think that's the difference between just sending an alarm out into a facility and orchestrating a response with your organization. And just one thing to call out, I think, especially as we're about to show the demonstration alongside two platforms alongside each other, it's important to understand that this does not replace any control, SCADA, MES, or existing platforms you may have already. I think these systems continue to identify and expose events and do their own functionality. I think what SQUEAKS provide is the coordination layer for event response that carries selected events to humans and allows us to preserve the resulting data. So without further ado, we can start to move into the technical demonstration. So here we have two different platforms. We have SQUEAKS on the right, which you can see is kind of this poster board of incidents at the moment. And on the left, we have more of what we'd call a classic OEE dashboard. We've got two views here. One is kind of this supervisory view, looking at various event times and their occurrences, or breaking it down by specific downtime. And we can see some various availability performance metrics. And so something like this would be maybe what an individual looks at to see, okay, we have a certain amount of occurrences of events, and we have a total downtime in some amount of minutes. And that's kind of it. That is what we'll get. The machine captured the start of one of these events, and then it was resolved, and in the tag layer indicated to the system that now that is resolved. So taking all of these individually can be, it provides information about where the gaps were in our production environment. But as a whole, it doesn't give us the granular discussion points that we've discussed already. And I think that's where Squeaks comes into this, to the picture here. So I'm going to go ahead and we're going to have a fault occur on a machine. So we'll go ahead and we'll look at the we'll look at the operator view for this machine, and we'll notice we have indicated an alarm here. So this is your classic alarm banner, and I want to show something. This alarm was integrated. This ignition project was integrated with Squeaks, and now we see that an incident has appeared with not only the basic information of a of a specific label or a PLC code, but we have a e-stop pressed, we have some tagging and logic, we also have embedded troubleshooting metrics, and an interface for an individual to be able to respond to this. So I think already you can see that this has been quite enriched by just moving this out of just the kind of controls layer or dashboarding layer into a purpose-built orchestration layer. So with that, we have we also have something here that I found quite unique and fun to work with, which is the API aspect between Ignition and Squeaks was very easy to use. So we're actually indicating to the operator that this is an open alarm. So currently, no one has addressed this alarm. It is open and it is affecting this operator's line or cell at the moment. On the other side of things, we'll see Squeaks is working in the background as that orchestration layer, and it now has escalated this event for being in an open state for too long. So apparently I'm taking too long to address this e-stop, but it's for the best that we kind of recognize this. So that's that automated escalation in progress right here. And especially for something like an e-stop where oftentimes it can be addressed in 1 minute by closing the cell door, resetting the cell, and moving on. But if that doesn't occur within that minute, this organization has defined that it should be escalated to a maintenance personnel. So from here, I'm going to play the maintenance personnel, and I'll go ahead and I will acknowledge this fault and I'll claim the responsibility. It's not just an open acknowledgement that an issue exists, but I am a responder saying that I'm going to claim it. And I can enter some nice comments here, but I will just go ahead and say I've got it. And you can see we actually have some feedback back to the operator. We're not just looking at a red box that shows us the issue that we already know. It actually says that this issue was claimed. Your alert was heard, and someone is potentially on their way to assist. So from that point, we're in this 25% complete board. And this is what we talked about with predefining these workflows and these stages. We were at 0 when this was completely open. Someone has taken accountability to resolve the issue. And now we have moved to the next stage in this incident resolution. So from here, what I'm going to do is I'm going to use these predefined workflows to actually say that I'm at the location. And I think at this point, it's worth it to call out that Squeaks works on desktop as well as iOS. So if you're using this on a smartphone or on a tablet, it will work with that as well. So I will go ahead and say at location. But again, this has now gone to maintenance supervisors. So because this has remained in a claimed state for longer than it should, it has now escalated. So I'll go ahead and so we make our team happy, and we will define that we are at location. Perfect. And so now we've moved to this 75% complete, and the operator has now also the understanding that someone is there and is actively assisting. And one of the things that I kind of worked with when I initially started working with Squeaks is that I wanted the data to be consistent between the human reporting aspect and the machine downtime event. And so Squeaks did something very good with this aspect, is that to close this event, we need to actually have it resolved on the machine side. So an individual can't just respond that they have it claimed and then potentially close it out while actually having the machine fault stay in an open state. And also for the back-end reporting aspect, we're going to have extremely cohesive data for our downtime events. We're going to have the exact same downtime duration. We'll just have a lot more granular step-by-step information from SQUEAKS. So we'll go ahead and resolve this issue. And you can see we have no active alarms. On our other side, we have our item as completed, and our banner to our alert to our operator has gone away. So I think this is an extremely important and nice workflow. I've been in many facilities where individuals are waiting at a stop cell, they're calling on a radio, they are escalating to team leads and supervisors. So I think this API platform really makes it simple to be able to provide that information back to the people who are waiting on some sort of support. So I wanted to show just this OEE side by side with SQUEAKS and kind of showcase just that easy integration between the two. And for a more in-depth platform review, we're going to jump over to Celine for a little bit of expertise within the platform.
Excellent. Thank you, Jonathan. Let
Absolutely.
me share my screen. Second. Perfect. So what you see in front of you is the SQUEAKS web application. As Jonathan mentioned, we have a SQUEAKS web application. We have iOS and Android apps that can run on mobile devices, tablets, as well as the smartwatches for both Wear OS and Apple Watches. We also have a Microsoft Teams app. So our goal is to really extend your operational visibility across in all your platforms, all your devices, where you can see that data no matter where you are. And as Brooks and Jonathan touched on, we are a very open platform. We want to make sure that you're able to send your operational events and incidents to SQUEAKS from anywhere. So that can be your SCADA systems, your machines, your CMMS systems, your ERP systems, your MES systems, whatever it may be. That all can come into SQUEAKS, but you also can get data out of SQUEAKS to send to external applications, just like you saw in Jonathan's demo, where as the SQUEAKS workflow was updating, you were able to see that reflected on the HMI side, so that operator gets that insight and gets that feedback from SQUEAKS. So we have an open REST API and different ways that you can send data to SQUEAKS as well as extract data from SQUEAKS. But today we'll be showing the web applications you can see here. And here you're able to see different types of faults. So with each incident that occurs, just to go over some of the different components of the incident. Of course, you have the identifier that's unique to each incident at the top, and you'll be able to see this play a factor in reporting later on in this demo, to where you're able to look at each individual incident within your report and easily identify them. You can also put in what we call classification labels, where these are customizable key value pairs that can really be anything you want to potentially filter on for reporting. So it can be the fault type, maybe it can be the asset, maybe it can be the shift that it's occurring on, for example, different ways that you want to be able to filter and fine tune your data later on to better understand your operations. You can dynamically include with each incident. And as Jonathan touched on, the body of the incident, as well as any troubleshooting guides, videos, attachments that you want to include, is all dynamic. So a lot of times, maybe, in some cases, team leader goes out to the plant floor, they notice something, they want to take a picture of it, include that in that timestamp or in that digital trail of every action taken on that response. They can automatically do that within the application and really keep that in that digital trail of that particular response. And with every incident, you have a digital trail of every action taken. So I can go to each incident, for example, the one Jonathan created earlier. I can look at the history and scroll down to the bottom. I can see, exactly when it was created. In this case, it was created at WC05, for example, at 1:25 p.m. From there, it was escalated, and why it was escalated, to who it was escalated, who push notifications were sent to, so the exact users that received notifications for this, who took ownership of it and acknowledged it, when did they do that, any comments they added along the way, as well as change in severity levels. And all of that really provides a digital trail of every action taken from the time the incident occurred to the time it can be considered resolved. And this can also be printed. So as we talked about earlier, you have those end of shift meetings, or maybe you want to review different events that occurred in your operations. This is an easy way to immediately print out that particular incident, and you have that digital trail of every action taken. And as I mentioned earlier, you have where you can create customizable workflows and customizable escalation rules that are not only time-based, but also severity level based. So maybe after a certain amount of time, or maybe after it reaches a certain state in the workflow, this is escalating, for example, to a level 2 severity level. That's all easily customizable within the application. So for example, just to show real quick, if you're wanting to set up workflows, as we touched on earlier, needs to be very intuitive, where anyone can do it within the UI. So as you're creating workflows, you define the states within the UI. You can define the actions on how you get from one state of the workflow to the next. And you can even define weights. So as you saw that progress bar on Jonathan's example, as he was stepping through that workflow, you're able to define, which states in the workflow progress you how far. And that's all completely customizable through the UI, no code. And the same goes for those escalation rules as well. But shifting back to the incidents view, not only do you get all of the events in the form of interactive and adaptive cards, you also have, from a manager's perspective, an activity dashboard where you're able to see a current activity for all of your incidents. So how many do you have open? How many are going to be in an escalated state currently? Different levels of severity, how many are unassigned? And you have some averages for your different incident types, the time, severity levels as well. At the bottom, you can also get a good grasp of, a quick link to your unassigned incident, any information with them, their current status, their classifications, and so on. And on the left-hand side, you get out-of-the-box metrics for what is your mean time to assign, what's your mean time to resolve, what's your mean time to acknowledge, for example. These are all being tracked dynamically within the applications as users and team members are interacting with these workflows. And now that you have this new data set on your response intervention gap, now you can have insights on that with out-of-the-box reporting. So I'll go over a few example reports, but these reports, again, are all customizable and can be sliced and diced based off your needs and what you want to drill down into. So for example, we have an incident summary report where I'm able to look at all of those incident IDs, so the different incidents that have occurred individually, and get a good timeline of, what was their time period in each state that they entered. So in the open state, the claim state, when they arrived to the location, how long did it take in each step of that workflow to resolve that incident? And down below, I'm getting a good summary list of every incident taken, information on that incident, and I can even dive into the history of that particular incident from here as well. So again, who took ownership? How did they interact with the workflow? What did they do to resolve that issue? And I can easily export that information as needed. Some other examples are, for example, if you have a user assignment report, I can look at all of the users in the system, see how many active incidents they're currently assigned to or working on, and again, look at the details of those incidents, see how far they're progressing as well. And the last report I'll touch on is another example of a team member assessment report. So you have maybe different team members that are working in particular areas on different shifts, and you want to better understand, is there ways to improve their response times, resolution times? So as we look at these different team members, how many incidents have they been assigned to? What's their duration to resolve these incidents, average durations, for example, and you can kind of look at, is there something where maybe they need additional training, maybe they need additional support, maybe they need, again, additional team members in that area on a particular shift, because there's certain incidents that are occurring more on one shift than the other. And again, it gives you new context and new data set that you maybe didn't have before, to really better understand how can you improve those response times, resolution times, and ultimately reduce costs and reduce downtime. So now I'll kick it back to Jonathan to complete out the presentation.
Awesome. Thank you, Celine. Fantastic. So we just covered quite a bit of information. So I just want to kind of discuss about the closing the gap with SQUEAKS. So this demonstration brings us back to this 5-stage life cycle of detection, alert, acknowledgement, resolution, and measurement. So these first 4 stages restore production, and that is an extremely important process. The 5th stage creates the basis for improvement of the restoration of production. So by recording who acted, when each transition occurred, and whether escalation was required, I think the organization really gains more than just a total downtime measurement. It gains a response history that can then be analyzed against each event type, shifts, production areas, and facilities. And with using the software, I really enjoyed how much rich data was available, and it was extremely interoperable because of that open API. So I think it's very useful for interacting with other systems within your manufacturing technology stack. That analysis kind of helps distinguish whether improvement is needed, and kind of the different routing or ownership standard operating procedures that you could implement. So the same data can also strengthen the relationship between departments, especially operations and maintenance or engineering and reliability. Both teams work from one timeline now rather than separate recollections of events. And this purpose is not to just score individuals or departments, or create a leaderboard, but it has to be interpreted within the context, including the complexity, staffing, production conditions, all of those things. And its value is in establishing a baseline, something that you can iterate upon, improve, and roll out new processes to just become better at incident response. One incident may explain a specific failure, and a trend across those incidents is what supports a management decision. It's something that we pitch with OEE and additional data dashboards often. That's where this information becomes just extremely useful for continuous improvement, instead of just like classic incident documentation of like a postmortem report. So this is how the gap is closed, not only by communicating the incident, but by making a complete response lifecycle. So you've seen a demonstration, and I just want to pass this up to Brooks. So how can a manufacturer kind of get started down this path of implementing something like this, or just a full lifecycle incident management and orchestration platform?
Definitely. I think the first key component is doing a pilot or a proof of value, which I know I talked to Nader about consistently. Nader, do you want to elaborate a little bit more on that?
Yeah, thanks, Brooks. So first of all, I appreciate the three of you doing this very technical demo. It really makes people think about the perspective of the gap, and then gives you guys a perfect platform to talk about it. It is aligning in one of our extreme ownership things that we at Flexware really pitch towards, and the SQUEAKS platform allows everybody in the process of having the extreme ownership of the alarm and any events that occur on the floor that needs the attention. So talking about the pilot, Brooks and I and Flexware and IGear together have come to a very good conclusion and agreement that we can offer people who are on this webinar, existing customers who know what work Flexware does, and customers who want to touch and feel the SQUEAKS software. IGear has offered to give a 30-day no-cost licensing ability, so we could give you that 30-day license, and Flexware offers to help set up and understand what that pilot would look like. And once the pilot is defined, you guys run it. If there's an additional services required, Flexware is happy to quote those services for you. And then part of the pilot, we will have a 2 weeks check-in to understand if you had a good experience with the pilot, with the 30-day free licensing of IGear, and yeah, basically make sure that you have a good runway to see if this is a good fit for your organization or not. Back to you, Brooks.
Yeah, thank you. And to kind of close that message, that'll be part of the follow-up email is what that offer includes, but those are the key components.
Yeah, awesome. Thanks, Brooks. And I think as we kind of start to think about the actual manufacturing experience and kind of who is this for, I'd like to just have like some back and forth with you. You know, iGear, you mentioned you've been around for a while. You've been iterating on this product now for multiple versions, and so just getting your insight would be really helpful. So I guess like when manufacturers first come to you, and iGear as a whole, I guess where does their response workflow, what does it typically look like now, and where do you often see this delays or ambiguity?
Yeah, great question. So a lot of times when manufacturers or customers approach us, they have different ways that they trigger incidents. So there's some incidents that maybe are from machines where they have some kind of sensor or maybe a PLC that's capable of understanding when a machine drops out of automatic, maybe even capable of understanding what type of fault it's experiencing. And that's kind of how that's reflected. And that may be showcased on an and-on display, for example, above the line. Maybe somebody gets on a radio and makes a call about that. We also see, stack lights, for example. So there's push buttons that are hooked up to PLC that's also connected to a stack light. Maybe operator needs to call for a team leader, needs to call for additional parts, quality, whatever it may be. They press a button on the stack light and that light's blinking. But a lot of times with all of these different forms of creating incidents or calling for particular different members of different teams, they really don't know, if that responder is around, how long have they seen that incident, if they've even seen it at all, from the stack light, from music playing sometimes, from an and-on display, from a radio call. And so it's really difficult to know who owns the incident, maybe sometimes how it was resolved, and was it dispatched or did it go directly to the user? And that's typically why they approach us.
Yeah, fantastic. I've definitely experienced that with, a downstream cell has been down for 30 minutes and then it finally stops a, high producing upstream cell and everyone, is surprised. So no, it's good to hear that you address that. And so I guess to the measurement aspect, when organizations begin measuring this, full life cycle of incident, what trends surprise them, or what is kind of interesting to them once they start seeing this full picture of data?
Yeah, good question. It's similar to what Celine already kind of mentioned in her previous comments, is this idea of what's our baseline. Without tracking it, they don't really know what their mean time to respond is or where they're losing time in their resolution process. So I think the big thing is having that new data set that they didn't have before to drive continuous improvement is what I've seen.
Awesome. Fantastic. And then I guess how does the conversation change once discussion is from this like total downtime to this alarm generation? Are you seeing, further collaboration or any specifics on the shop floor?
Absolutely. So as we talked about earlier, in those end of shift meetings where they're reviewing the different incidents, reviewing downtime, for example, now they have a better understanding of where time is lost, that they have this new data set. So they're understanding with every incident that occurs, who took ownership, what actions do they take, is it a streamlined process, how can we improve that process, where is time lost, and then from there, again, as Brooks mentioned, they have a baseline on how to improve, and there's no more finger pointing. They can really create countermeasures to improve their processes and ultimately reduce downtime, rather than just talk about we track downtime, for example.
Yeah, fantastic. I guess just from we're an implementation arm. So I guess what does a strong intervention workflow look like, or a fully adopted SQUEAKS implementation?
Yeah, I think there's not a one size fits all. I mean, when we built the platform, it was really trying to make it user configurable, whether direct or through one of our certified integrators like Flexware. So I think it's very important to be able to be open to what that end user is looking for in their problem resolution process. So that's really where Flexware comes in, is to be able to help us have that domain knowledge of their end user and the expertise to take our technology and configure it so it becomes valuable to the actual customer. And we've seen a couple different examples. One would be a dispatcher assignee process. So when an incident occurs, we make sure a dispatcher sees it via notification, and then they dispatch it based off the incident type. And we've also seen one that goes direct to a specific responder or team based off incident context and responder profile. So really trying to meet the customer where they are, and make sure that this platform can accommodate for that.
Yeah, well, thanks, Brooke. I know that flexibility is extremely important. Fantastic. Well, we've covered kind of our manufacturing experience. So I just kind of want to pass this off to Ellie, and we can address any current questions that we have.
Yeah, thanks, Jonathan. We have a couple questions that have come in, but if you have any other questions, feel free to drop those in the toolbar in the questions tab, and we'll answer them as they come in. But first one here is, what are some use cases of SQUEAKS in the field?
Yeah, that's a great question. So I'll give probably 2 examples to go over quickly. But first one, we have a customer that uses a vision system. So this is kind of a more automatic based incident creation. Their vision system detects quality defects. So anytime a quality defect is detected with their vision system, it automatically creates an incident within the SQUEAKS platform that has a certain resolution process based off that type of quality defect. And what saved them a lot of time with that is that, before they used to have to walk, a lot of times the teams responsible for resolving those issues, 15 minutes to get down to the floor to see what's going on. Now they can immediately really understand what's going on, what it's going to take to fix it, and who's the best person responsible for resolving that. A second example would be from, for example, a lot of our customers in the automotive space that are automotive suppliers, they have team leader dispatch. So maybe they still have an operator that's interacting with a stack light push button just like they typically do. But now when they press that push button, that automatically sends an incident targeted to a team leader. That team leader receives a notification from the SQUEAKS mobile apps. They're able to come to the scene and kind of see what's going on. And then based off that and based off the context of the incident, they can dispatch and assign a particular responder to come resolve that issue.
Awesome. Thanks, Celine. Second question here is, can we start with one department or production line and expand over time?
Yes, I could take that one. I think recently we did a specific use case with an automotive supplier, and they started with one line. And their goal was to improve their andon capabilities, prove out the platform, and a specific workflow that pertained to their team and what they wanted to track to improve. And so that's where working with a certified integrator like Flexware, we're able to tailor it, get one line up and running, prove out the software, and then deploy across multiple lines of the operation.
And to add to that point, because the platform is so modern, the time to get going is not as much. This could all be set up as long as there's a existing digital infrastructure that you have access to your data points. This can be spun up really quickly. And to the previous question, I would also like to add that, from a management perspective, there's always a struggle from the organizations to get people on the floor to own a certain part of the thing, because the manager's handshake, you just do this because it wasn't my department. Somebody else should take care of it. But if you incentivize and basically gamify, and I know Brooks knows this because we've talked about this in the past, but if you using SQUEAKS, if you gamify and say, hey, look at this, we had 65 incidents and your player number 1 and 2 are actually very good and they're responding really, really well, and that could be like an incentive program for them. So this finds better ways to motivate people, and there's factual data behind it, so organizations are able to solve problems not just from a business level, but also from a cultural and a morale level.
Definitely. Thanks for those responses, guys. And then last question here is, how does SQUEAKS improve communication without creating more notifications?
Yeah, I can take that one, Ellie. That's a great question. So, with Squeaks, what we found when we were working closely with customers and starting to create the platform, it was if you receive too many notifications, you're more than likely going to ignore them. So, our goal was to really create a quieter and on system that's really targeted. So, based off the context of the incident, I know we keep talking about that, but it's, the location the incident occurs in, the shift, maybe tags that identify the type of fault, for example, if it is a fault-based incident. Any operational criteria set that you can define with that incident. We want to make sure only the people that are interested in this or responsible for resolving that type of issue or being aware of it are notified. So that way you're really only receiving notifications based off of what's important to you, what matters to you. And you're able to easily set up those filters within the application, within the UI. So you can create teams that are tuned into particular tags or even keywords, labels, classifications. And then you as a user also can define what shift you work on, what areas you work in, even the type of levels of faults or incidents that you're able to resolve on your own, your skill set pretty much. And then you only receive notifications based off that. So it's very quiet, targeted, and on type system.
And to add to that, there will be more of that showed at the ICC conference show that we're having in September, which will showcase not just the level of detailed catered notification going to people who are responsible, but also leveraging AI and agentic workflows that will help you identify the right individual who should be brought attention to those events, and how not just a drag and drop type workflow, but like it could be a creative workflow that needs to be on the fly created, and that's where agents would come in and be like, okay, this event is not something that has happened in the past. It needs special attention, so this should go to somebody who needs to pay attention now. So let's call somebody, and it'll call somebody.
Definitely. Add one more point to that, Nader. I think, we'll be out there showcasing our new SQUEAKS module for ignition. So just making it even more integrated with platforms you're already comfortable using day to day. So.
Yep. So perfect example. So it's right there. The module within Ignition will basically not create any more notifications because you're just there. So you don't have to switch screens to go see who's responding to what, like we showed today with that one banner. But IGear has gone ahead and created a module that integrates directly within Ignition. So now you don't have to worry about doing all of that, what we did for the demo. Again, that was really quick and it was very easy to do. But the more easier it is to integrate, the better, right? So, yep.
Absolutely. Well, thank you to all of our speakers today. I really appreciate the time, and thank you to everybody who joined us. Hope you learned a little bit more about how you can minimize the time between detection and response. Like we mentioned, keep an eye on your email for the recording of today's webinar and for that exclusive pilot offer that we have for you. And just like Nader and Brooks just shared, if you are going to be at ICC this year, don't miss the Technology Ecosystem Showcase, where IGear and Flexware will be sharing more about SQUEAKS. So thank you and have a great rest of your day.